June 22, 2023, 9:17 and 34 seconds p.m. Topic: Faraday Paradox Revisited Magnetic Field Rotation Question. Hello, I decided to start this topic because I want to summarize all we know about Faraday disk paradox in one topic on this forum. This may be helpful for further homopolar generator study. The most important question is, does magnetic field rotate with magnet or not? Let's consider a situation like this. A coil is wrapped around a magnetized core, cylinder magnet. Both the coil and magnet are rotating together around the axis of the cylinder. Will current be induced in the coil? This permanent magnet is ceramic, not iron. This should stop any induction taking place inside the metal body of the magnet. If magnetic field does not rotate, this will simplify things and eliminate unwanted effects. Anyone tried this configuration?
I see where you are coming from here. Most likely the windings will have to have more angle from top of the mag to the bottom in order for the fields to cut the windings properly. At 90 degrees is best, but if the windings are tight, each turn is more closer to 0 degrees, higher angles would mean less turns and less voltage out.
I like the config though. If the windings have more than 0 degrees angle, there should be something. Being it is one magnet and it is not dragging the mag field around like bunches of mags, the field should remain still like a big disk. But only if the magnet's field is uniform. I have some neo-mags that the poles are not center, as in stronger off to one side than the other. So that may be an issue.
I've seen guys use a bunch of little magnets in order to try and recreate a large disk mag. But the reason it does not work is we need the magnet to be one piece. When the magnet is a big ring disk with a hole, like a speaker magnet, as the magnet spins on axis, the field doesn't spin or move in rotation with the magnet, so if the copper disk spins with the magnet, the field cuts the disk and you get output. Using a bunch of small mags to make the disk screws all that up.
I'll see if I have my old drawings of what I thought may work. It was alternating mag disks where there would be say a N/S pole ring magnet goes on the shaft first, then a copper disk, then another N/S magnet, in attraction to the first mag, then an iron disk and then a S/N magnet in repulsion to the second mag ring. The iron disk should capture the two S fields and direct them to the shaft where the fields have a path to the other poles without breaching the outside diameter. This way we can add another copper disk that carries current inward, where the first copper disk carries current outward. Then we can have a stack of mags and disks that we can make electrical connections from an out disk to an in disk at the outer edges, which will give us a bunch of plates in series, in, out, etc. to increase the voltage like more windings would do.
The most important question is, does magnetic field rotate with magnet or not? Anyone tried this configuration?
Hello, Polexexebulaxec.
I think this resembles what you have there, just applied in a different fashion. And a YouTube video, probably nothing new to the forum but interesting nonetheless. https://www.youtube.com/watch?v=g2way09SMAE.
Methinks it's all about frames of reference.
If the windings have more than 0 degrees angle, there should be something. I hope so. The brushes, it's a thing, they are stationary, they should be welded to the disk when everything rotates together. Would be a current then? If magnet spins and disk is at rest, there is no current in disk, so magnet field must not rotate with magnet, right?
Can you give me a schematic for simple amplifier that will light up a LED when small DC current is detected? I will try to build this.
Ceramic magnet is important because of this. I also wish to see no brushes version, wires welded to magnet. Disk rotation relative to return path. And we still don't know if the field rotate or not. It's not important if the field rotates with the magnet or not. The problem results from a uniform field where, because it's uniform, will simply slide and do no work. It must be forced to cross a conductor to induce a current, and yet because of this it still produces the counter EMF. If it did not, then a simple unipolar motor would not operate. A unipolar motor rotated by a mechanical input will become a generator for the same reason.
The principle of counter EMF is what makes all motors and generators work.
The instant any current is produced in a conductor by movement through a magnetic field, that very same current generates an opposite magnetic field that fights the movement direction. Look at a speedometer, what more than a rotating magnet? John.
Okay, but when magnetic field is moving trough space it produces inducted electric field, right? According to Faraday, test charge should experience a force near spinning magnet like so. So field is moving with magnet but no induction in stationary disk?
Lens is lens, Lorentz is Lorentz, but there should be non-zero current detected in disk. In the case of something like the speedometer there are small rotating eddies set up within the disk. John. Once you consider all the cases of a Faraday generator you will see the problem. How about magnet stationary but disk and contact spinning equals no charge?